Good afternoon, everyone, and thank you for participating in this Tech Talk. This is one of a series of Tech Talks that we'll host to get information out about innovative companies, organizations, and events that we have within our region. For those of you who aren't familiar with NavalX or the Tech Bridge structure, the Mid-Atlantic Tech Bridge is one of 18 tech bridges across the country, and our primary mission is to connect innovative companies, organizations with DoD problem sets. And part of that is giving this great information out to the right audience so that you guys can be aware and take action. We have a limited time here and a lot of information to put out, so we're going to get started immediately. But again, thank you for participating, and thank you to our PS 757 Collab and C5BDI for helping us put this one.
All right, and next we're going to have Mr. Paul Davis to walk us through Trident Spectre.
So good afternoon, good morning, wherever you sit. My name is Paul Davis. I'm the former Trident Spectre Deputy Director. I'm here on behalf of Mr. Brady Bodcock, who's the Director for Trident Spectre. But before we get into Trident Spectre, so Trident Spectre is the Naval Special Warfare Command's premier innovation and experimentation. So I want to just give a quick overview of what Naval Special Warfare is. So here's just a quick mission statement of what Naval Special Warfare is. We are the premier maritime soft force for U.S. SOCOM. Naval Special Warfare is one of the 5 major components of U.S. SOCOM, as indicated in this slide. The Naval Special Warfare itself is broken down into Naval Special Warfare groups. So Trident Spectre is run out of Naval Special Warfare Group 8. Groups 1 and 2 are what is known as the traditional numbered SEAL teams. Group 4 is the Maritime Special Operations Surface component. And Group 8 is the subsurface and special activities component. Group 11 being the reserve, development group being test and evaluate, and the center being for the basic. So this just gives you an idea of what the Naval Special Warfare operator looks like. On average, they are about 31 years old, and most are college educated. Some have a postgraduate degree before even attending selection. You can see some of the specialized training that those guys get when they come through the gates at the center. So this is just a quick overview of the surface maritime components that we have within Naval Special Warfare. And our subsurface components. And the reason this is relevant is because it's going to directly correlate to the types of technologies that we're interested in. Next, please. So with that understanding of what Naval Special Warfare, we're going to get into Trident Spectre. And again, like I said, Trident Spectre is the primary innovation and experimentation event that Naval Special Warfare does, primarily run out of Naval Special Warfare Group 8. Next slide, please. So this is just a brief overview of what Trident Spectre is, but more importantly, what I want everybody to understand what it isn't. So it is not a typical trade show. What we do with Trident Spectre is that we try to bring our operators into this exercise under a operational scenario to execute full mission profiles alongside industry partners and projects that were selected into Trident Spectre. It is a highly competitive process. Last year, we had about 328 submissions. Trident Spectre only selects 75 of those submissions because we do see particular gains and rewards coming out of Trident Spectre for the military, but for the industry folks, what you guys get is an extreme amount of exposure to the soft community as well as the intelligence community to collaborate and create new technologies and capabilities that meet the nation's needs. So Trident Spectre has been going on since 2005. So in 2005, we realized pretty rapidly after the war on terror started that we were severely under-equipped on the battlefield to deal with the adversary. So we stood up Trident Spectre to rapidly develop technology that would help us fight the counterterrorism fight. And over the years, we have seen that fight evolve to the new national defense strategy in 2018 to get after what we call peer and near-peer competitors. So we pivoted Trident Spectre in 2018 for 2019's Trident Spectre to go after peer, near-peer competitors, or what we would call deterrence.
Integrated deterrence.
Integrated deterrence, in accordance with the 2018 National Defense Strategy. So we've been going on for about 17 years now. This is the mission for Trident Spectre. So the paragraph is a mash together of a bunch of buzzwords, but really what I want you to pay attention to is the bumper sticker there. So what Trident Spectre does and tries to do is to shorten the acquisition kill chain for bringing technologies into the DoD and the IC so we can field equipment rapidly to the warfighter. Most of you who are on this call probably understand the bureaucratic and complicated way that DoD does acquisition. Trident Spectre is not designed to circumvent that, but we are designed to rapidly iterate so we can beat milestones that are typically take anywhere from 18 to 24 months in order to field equipment that the warfighters can use on the battle space. Next slide. So the way we do that is 3 lines of effort. So you see there's operations, technology, and intelligence lines of effort. This is Trident Spectre at its core. Operations is exactly what it sounds like. It's a team of soft operators who do full mission profiles with emerging technology in a relevant environment. Intelligence is much like the operations line, where we bring in intelligence professionals and they put the technology through a full battery of intelligence scenarios as they would in their normal day-to-day against any adversary that they would come up against. The technology line of effort is broken down into 3 different teams. It's broken down into a functional assessment team, a technical assessment team, and a vulnerability assessment team. This is where a lot of the industry folks, as well as the DoD decision makers, get a lot of their information. Because one thing that we realize, our currency coming out of Trident Spectre is data. And the data that we get from our assessments is what the decision makers use to make ultimately acquisition decisions. So within the technology line of effort, the technical assessment team is a team of subject matter experts that will take the technology or your project and do a full assessment from a technical standpoint from the subject matter expert. So if you say this switch does this, or this box weighs 10 pounds, they are going to verify that exact claim. The technical, sorry, that was the functional assessment team. The technical assessment team is a team of scientists and engineers that take your technology and they verify the ones and zeros. So if you say you're emitting at 3 dB a gain, they're going to take your technology and check that. And then the vulnerability assessment team, we bring in the Joint Vulnerability Assessment Branch out of San Antonio, Texas, and they do a full computer network systems and RF vulnerabilities of your technology to highlight and identify any potential vulnerabilities there are. Now, none of these teams are there to stump the chump or to poke holes in your technology. What we're there to do is to either verify or not verify the industry claims and also to give you the information for future development. Some people will say, well, why would I want to put my technology through all that battery of assessments? Because I know my technology works. Well, you may think your technology works in a lab or on a bench, but what we're really going to do is we're going to assess your technology in a relevant environment with subject matter experts. And what you get from that is you will get critical developmental knowledge on either how to correct any kind of discrepancies, or it's going to validate your current developmental roadmap. Some industry partners will develop their technology in kind of a vacuum without operator input. So really what this does is gives you a azimuth check to see if you're actually on the right path or if you need to move your development in a different way in order to be relevant for the warfighter on the battlefield. The operations line of effort does that, but in a much different way. Whereas you as the industry partner get to select technical, functional, and vulnerability assessments, our operators will select from the selected projects whether or not they want to bring those projects into the ops line of effort. Same thing goes with the intelligence. The reason that is so important is because our operators have the most recent and relevant information of what the problems are on the battlefield. We as staff members, we don't necessarily have that relevant information, so we rely on those returning warfighters to select the best technologies that are going to help them get the mission done. So here's just a quick overview of the technologies that NSW Group 8 is interested in. This is not all encompassing, and this does change from year to year. This is what we showcased at our industry day last year. Our industry day is coming up this year on the 18th of October here in Norfolk. It's an in-person event. And you can register for that through the Vulcan website. And I'll get into a little bit about what Vulcan is here in the next slide or two. But these technologies are what's important to Group 8 and NSW WIT at large. It's not all encompassing, although you'll see some things on here, but if you've got a technology that's outside of these points, please feel free to submit, because regardless of what we say we're interested in or what we're not interested in, our stakeholder base, which is about 50 different organizations from DoD, the IC, and SOF, may have an interest in your technology, regardless if it's up here as one of our technologies. So the players. So Trident Spectre is broken down into basically 4 different groups. Staff is staff, and we all know what staff is. They're the ones that plan and coordinate the event. Stakeholders, as I mentioned before, we have about 50 or so different government stakeholders, and they're all the way from Customs Border Patrol, all the way through the intelligence community. Primarily it is with SOF, and primarily it is with DoD, but we do have non-DoD government stakeholders. We have several IC stakeholders. What they do is they help us nominate projects, and they also help us select projects, because we try to do this in a collaborative environment. That way we understand the wider DoD's requirements. Government sponsor. So every project that comes to Trident Spectre must have a government sponsor. We do that for a couple of reasons. Number one, we don't have the staff or the bandwidth to really usher each project through the selection process. So we would ask a government sponsor to nominate a project and do that for us. And what does ushering through the process mean? It means reviewing your submission, making sure that you're answering the questions that need to be answered for selection, and really some of the logistical challenges that you may have when you come to participate. Some people don't necessarily have base access, so the government sponsor will help get a project access to the base and things like that, whereas the Trident Spectre staff is not staffed nor designed to do that. Capability providers are you. So industry partners, academia, other DoD labs are all capability providers. So it's not just vendors. So you'll see capability providers coming to Trident Spectre with projects. They're not necessarily an industry partner, could be a university from an academia organization or one of the UR research laboratories. Next slide. So project selection. So you may wonder, how do I submit? How do I get selected? Where is all this done? So we use a platform called Vulcan. It's www.vulcantaxsoft.com. You can just Google it and it will come up. So what you do is you submit your project or your scout card onto Vulcan under the Trident Spectre advertisement. There's NSW and SOF uses Vulcan as a tech discovery tool. So even if you're not applying for Trident Spectre, I highly recommend that you put your technology onto Vulcan so it is discoverable from the wider DoD audience. Because not only does SOF use this, the wider DoD uses Vulcan as a tech discovery tool. And there's many other calls apart from Trident Spectre that are advertised in Vulcan. We use Vulcan as our collaboration portal. We use it for project submission, nomination, selection, and once we get past selection, we use it for the collaboration portal during the execution of Trident Spectre. There's many features of Vulcan, way too many to go into this venue. But I highly recommend that you get on the Vulcan, submit your technology on there, and then you'll be able to see when the Trident Spectre, if milestone events are being advertised, they will advertise in Vulcan, and you will get email alerts notifying you when those advertisements are available on Vulcan for you to go in to register. Again, projects will be selected with our stakeholders and partner with our stakeholders. Again, it's a highly competitive. We only have the bandwidth to provide quality assessments for 75 projects, which is why we have a selection process that is as competitive as it is. So it's all metrics based on our stakeholders get a vote according to the metrics that are set forth by the Naval Special Warfare Group 8 Commodore. And those are the metrics that we use to select all our projects. We discuss all these selection conflicts with our stakeholders at our working groups. So if one particular agency wants something that didn't quite make the cut, it's a conversation, not just a hard, fast, and no. So this is really my last slide to go over the overview of Trident Spectre, but you can see here the Trident Spectre 23 planning dates. I'll leave this up there. I will get with the Trident Spectre staff to see if these slides are going to be published in Vulcan. But if you do have questions of anything that you've seen today, you can email Trident Spectre admin@socom.mil for any future questions or comments. And I believe that email address is on Vulcan as well. So if you're already on Vulcan, you should be able to see that email address. But Trident Spectre, as it's spelled there on the slide, admin, ADIM@socom.mil. Send your questions to that, and the staff will get back to you or answer your question as soon as they possibly can. And with that concludes my presentation. I'll give time back to anybody else that needs time, and I'll be standing by for any kind of questions that come up on the chat.
And I'll also add, we'll have the link to the industry day at the end of the slide deck, and it did shift one day to the right. So it's actually 18 October is going to be the industry day down here in downtown. So again, we'll have the Vulcan link for that at the end of the presentation. Okay, so next up, we have Mr. Chris Knapp with Persistent Systems. And so the next few speakers you're going to hear from are actually, helped with Trident Spectre and participated in Trident Spectre this last year. So you're going to kind of learn a little bit about their company and then their experiences with Trident Spectre. So without further ado, Chris, if you want to come up, mute, and the floor is yours.
Appreciate it. Thanks, Tina. Thanks to the NavalX team. I am Chris Knapp with Persistent Systems. I'm going to start with telling you a little bit about the company so you can understand why we participate in an event like Trident Spectre. Next slide. Next slide.
Yeah, sorry, Chris, there's a little bit of a lag with the internet
Okay.
and what's showing up. I promise I hit next slide, but give it a second. Chris, so I got booted off my laptop with the slides. Do you happen to have them available right there and could bring them up until I come back?
I do.
Okay, do you want to try and go ahead and share your screen? If we need to, we can make you co-host.
1 second.
All right, thank you.
Is it coming up?
Yep, I can see it, Chris. Thank you.
Can everyone see the slides?
Yeah, they look great. Thank
Okay.
you.
So
Yep.
we'll kick this off. So Persistent Systems is a US-based company. We're based out of New York. We established in 2007. It's owned by two individuals, Dr. Herb Rubens and Dr. Dave Holmer. It started out of trying to solve a DARPA hard problem, and it's how do you scale a mobile ad hoc network and maintain throughput. So again, based out of New York, we have about 240 employees. We've been growing as COVID and everything else has hit, and we just expanded into a new facility. And one of the key components is streamlined and modernized. We can punch out about 8,000 units a month with 3 shifts if needed. We have locations throughout the US, not only just in New York, but also in Pinehurst, North Carolina and Fort Collins. And we are the sole manufacturer of the Wave Relay mobile ad hoc network system. One of the key components of this is that it's a TRL-9 product that has been proven everywhere from underwater to space, also integrated on UGVs and soon the F-35s. The big thing that Wave Relay brings to the table is defining what today's data link needs to look like for the end users, whether they're in the field overseas or if they are here working for commercial industry. As the environment keeps changing, we need something that can adapt and keep up with it. And one of the key components of all of this is what I have outlined here. But more importantly, it's also that life cycle sustainable. So we are big on ensuring that our products have been proven in the field. And this is where it comes to our relationship with the Navy and NSW. The company started focused on the operator. And we ask ourselves every day how we can empower the operator with critical capabilities while reducing the physical and cognitive load. For any of you that have been in uniform or any of you that have watched the movies, this is not an uncommon sight. You see an operator in the field who's completely loaded down with gear, and there's got to be a better way to do this. We want to continue to outfit the operator, but do they really need to be carrying 12 batteries and 3 radios and all of these other capabilities? Or can we provide a network that can provide them the resources they need when they need it? And in that, it's not just the physical burden, but it's also the cognitive burden. As we empower these operators with multiple different sensors, we can push all the information to them, but at the end of the day, they can only absorb so much at one time. And in many cases, they're looking for the right information at the right time. So how do we do this? So Wave Relay is the proprietary algorithm that is running the mobile ad hoc network. Mobile ad hoc network is distinctly different than a mesh network. In a mesh network, you have a commander node, so a single point of success and failure that is dictating the entire network, how it operates, where each individual nodes are, and how to route the information. In a mobile ad hoc network, they talk about self-forming and self-healing, which means as nodes leave the network, the rest of the network functions independently. So local implications don't have global impact on the network. The differentiators for the Wave Relay is extremely low latency, 3 to 5 milliseconds between hop. It's highly scalable and high throughput. And we're talking 318 nodes on 120 megahertz channel, pushing voice, data, and video, and still maintaining 25 megabits up and 25 megabits down. We also work with the Army C5ISR lab to harden our algorithm so that it actively adapts to the environment, whether it's RF interference or jamming. AES 256 encrypted, FIPS 140-2, 140-3 ready, and there are aspects of how we operate that provide LPI and LPD capabilities. And again, cost effective, augment current systems. So as we know in dealing with the government, you can't just get rid of a system because you found something better. We've invested millions, if not billions of dollars into the networks that we have, and there has to be effectively a transitional period. So what that means is that we're able to bring on legacy systems onto the network and share that information throughout the network so that You don't have to get rid of the network you have, but you can augment it until you're ready to transition over. Also with that, because of the capabilities we bring to the table, you can have simplified network management where any node on the network can control the entire network, along with remote network access through our cloud relay capability. You can access the network from anywhere in the world. And what's really important, especially for the operators in the field and especially NSW and other soft units, is high mean time between failure. And by high mean time between failure, we have components that are in excess of 130,000 hours. And I think the lowest failure we have is about 60,000 hours. So this is our ecosystem. In the interest of time, I'm not going to step through all of it, but the key component is the MPU5 is our radio form factor data link node. This is IP68 rated, and it's what the users will wear in the field. And this is the vast majority of what we outfitted Trident Spectre operators with is the MPU5. When you combine that with the dual push to talk and the rugged display controller, you create our tactical dismount kit. The MPU5, along with the embedded module and the GVR5, are not just a data link node. They're also, in essence, a computer. They have on board an Android operating system, 128 gigs of storage. We only use about 30% of the processing power for our algorithm. The 70% that's left over is free to use for the end user. This is not locked down at all. You can load any Android program that you want. Everything from ATEC to Candy Crush will run on the MPU5, the embedded module, and the GVR5. The rugged display controller is your graphical interface with the MPU, so there's no processing on board. It's just your graphical interface. Push to talk makes voice, IP-based voice, simple and easy for the operator. The GVR5 is our vehicle-mounted solution. It's a dual-band solution. The embedded module is what you'd find in a lot of UGVs and UAVs. This is a OEM-type solution that requires, a full install, but obviously has a much smaller form factor. It's about the width and length of a deck of cards and about half as thick. Our MIMO tracker and embedded sector are our options for extending your line of sight. MIMO tracker will go out to 120 miles. The embedded sector, which was also present at Trident Spectre, is non-moving parts, 120-degree field of view. 3 of these will give you 360-degree coverage. We had 2 of these up in Trident Spectre, bridging the gap between Fort Story and Little Creek, with 60 megabytes being pushed between the 2. Cloud Relay is where we take layer 2 and layer 3 connectivity and make it a seamless transition. What does that mean? That means when you go from line of sight to beyond line of sight, it's seamlessly transitioning. The algorithm is deciding what is the best routing, whether to use the beyond line of sight capability or to use the line of sight capability. And this is all seamless to the operator for configuration all the way to execution. So you just plug in a backhaul device into the MPU. It could be as simple as your Android phone or your Apple phone, and it will automatically network configure it and allow it to use that 4G, 5G connectivity. So what does this all mean and how does this come into play? So building into what we did at Trident Spectre is not only provided a resource as the network, we also ran a project. Now, when you have a network that is IP-based and you're running it as a mobile ad hoc network, it's a decentralized network that doesn't require any established infrastructure. You can bring it up when you need it and bring it down when you don't. So taking an example of just IP-based video, what does that mean? If you look at something like Rover, which for those that are not aware is a video distribution system that the military uses mostly to pass video from airborne platforms to guys on the ground. This is a one-way data link that just pushes video. Now, if you were to switch to something that was bidirectional, something like the wave relay capability, now it's not just pushing information, but it can also pull information. So you can pass information to the guys on the ground as you're approaching. The guys on the ground can push information up to the platform. This can be video, this can be voice, this can be data. And you effectively can execute the operation without even speaking a word if you don't want to. And this gets into future capabilities of what soft units are looking for, is to be able to execute without using voice to minimize the impact that you have to the environment. When you start thinking about taking this to another step, you look at the applications that I have here. So you also give the operator access to various video assets, which means he can be receiving, or rather there can be more than one video being streamed across the network. So you can have 5 different video streams going across the network. but the operator is only going to receive the video that they request. This gets into lightening that cognitive load, and it allows the network to maintain its scalability because it's not pushing all of the information around the entire network. It's only pushing it to the nodes that are requesting it. Again, mentioned the two-way leadership or two-way interaction with the nodes. So that gives leadership worldwide access to the streaming video, which means back in the US, if you're operating overseas, you can plug in an MPU and be able to access that network from anywhere in the world through Cloud Relay. Additionally, can enable control and troubleshooting of systems and sensors. So for manned aircraft, we have a pan tilt zoom app, which gives you native control of gimbals, or you can leverage something like ATAC where you do a point camera here. Unmanned aircraft, you can do everything from indirect receipt of the data to full control of the aircraft for launch and recovery. And then remote maintenance, which is a key component for a lot of organizations, is to be able to access that system like you were sitting right next to it from anywhere in the world. That gives you an opportunity to troubleshoot it, or it gives you the opportunity, for example, to run payloads with the appropriate authorities and permissions. Now, as mentioned, we had a long history with Trident Spectre and a long history with the Navy. So the founders of the company cut their teeth with special operations, and part of that was through the use of GIFX. Paul didn't mention it, but GIFX is very similar to Trident Spectre. It's run by Naval Postgraduate School and has a lot of the same resources that Trident Spectre brings, except it doesn't have the longevity. So it's a lot shorter of an event, along with the fact that it also doesn't provide you that direct access to end users that have just returned from the field. But in the same token, it allows you to test your systems. And that's the key component of what we get out of being part of Trident Spectre, not just as a resource, but also as a project, is we can flex the capabilities of our system. Just because our products are at TRL 9 does not mean that there aren't things that we haven't had an opportunity to test and evaluate, because we're always doing upgrades and bringing new capabilities to the end user. And I'll have an example of what we did at Trident Spectre this year. But one of the other capabilities is, as mentioned, multiple entities separately and as a collective. So every time we come to one of these events, there are different organizations there, whether it be on the business side or whether it be on the government side, that allows us to work with them to integrate their systems into our network. While it's not rocket science by any means to run our network and use our equipment, there's always nuances whenever you're trying to plug and play something. And any company that tells you if you plug it in, it just works, we all know it doesn't ever really turn out that way. So in that case, we get an opportunity here to test real world equipment in an environment that is as close to an operational environment that you can get being in the States. Not to mention for us in particular, it's an RF dense environment. So this gives us an opportunity to evaluate our upgrades to our EW hardening, along with how we are managing the network in an RF dense environment. The access to the end users is an incredible opportunity to talk to either the users that have our equipment and have put it in the field, or those that are looking to do it, to understand what their needs are and what we can do better. Requirement developers and requirement executors. These are definitely distinct organizations and they have different interests. So in the sense of requirement developers, these are the ones looking for new capabilities to bring. And then the requirement executors are those that are ready to bring a new capability and are working off of what the developers have provided them. And they're always looking for the best capability to bring to those end users. And then of course, as I mentioned, already, test and evaluate network performance, security, RF agility. So for Trident Spectre 22, one of the projects that we supported was run by Maven, and Sierra Nevada Corporation was working with them. They had an aircraft that was airborne that had a wide area surveillance sensor. A wide area surveillance sensor does more than just the soda straw that you get when you point a camera somewhere. It instead is looking at miles of area at one time, and then using software to pick out important parts. So they had onboard processing that was sending cutouts down to those on the ground based on object identification. So in this case, it was looking for a ship. So when it found that ship, it sent that cutout down to the ground. It also had a full motion video sensor on board, and it slewed that MX-15 to the ship. And this was all automated, and this was all being pushed real time down to the ground along with the full motion video. On the ground, they were doing additional processing on the information to pull out more details of the object. With this, there were operators in the field running around with tablets that were pulling the information via video and using ATAC to adjust the camera angle on the MX-15 that was on board. This was all being done over wave relay. At that time, we also had divers that were in the pool down underwater, and we had the aircraft that was airborne. So the network consisted of from underwater all the way to the air. Additionally, we had cloud relay running via Starlink, which was giving us 100 megabits up and down to provide that information to any end user that needed it around the world. Along with, as mentioned, the 2 sector antennas that were put up between Fort Story and Little Creek with 60 megabyte shots. And when we talk about being able to flex our network capability across all of this, these resources are very expensive, and it is not often that you get an opportunity to do this, not only with these resources, but also in front of your end users. So you can provide that evaluation and you can flex the network, in our case, to see if there's going to be any hiccups, if there's going to be any issues, in order to ensure when it does get pushed out to the field, it is ready for prime time. With that, I have reached my time limit. Any questions that I can answer, I'm open to them.
So Chris, I think we'll hold those to the end just to ensure we have enough time to get through everything, but really appreciate your time and your perspective in participating in Trident Spectre. So thank you again. So
Absolutely.
I'm gonna try to share my screen again, and Mr. Mark Berry is going to talk to us next about his experience at Trident Spectre this past year. So let me see if I can get this up. Okay, perfect. All right, Mark, the floor is yours, and hopefully I can stay up on the internet.
Copy that. Thanks, Tina. Good to see you again, Dr. Stark, Mr. Davis, Mr. Knapp also. I'm a big fan of your company, Persistent Systems. The short of it is whereas they have a long-standing history, this was our first time. Hats off to Trident Spectre. You know, I enjoyed every minute of it. Sorry for the chaos I undoubtedly caused there, but I look forward to hopefully being there again next year. What my company represents, named Saltenna, from a saltwater antenna, basically perspective, is a technology. It's a new technology that was accidentally discovered while the top scientist there on my team, Dr. Igor Smolyanov, was working for Mr. Dendy Young, who was a chairman and founder of a different company before this one. They took something away from it that there's some type of quote unquote surface electromagnetic wave out there that no one had yet identified until us in the world as we understand it. So we use plasmonic theory and other metamaterials and other physics theories to go ahead and create these, we'll call them antenna-like devices to transmit, receive energy agnostic across the frequency spectrum. And we call them plasmonic surface electromagnetic waves. Next slide, please. So my objective for Trident Spectre specifically was to have brought full motion, high definition video underwater to the Navy. We had actually an Army sponsor that brought us there. He specifically wants us to perform communications over a couple frequencies and complicated environments to include dense urban, jungle canopy, and predominantly subterranean environments. So we're expecting a direct phase 2 from him real soon. We also have a phase 1 coming from Defense Threat Reduction Agency soon for subterranean uses. So again, it was important for us to get in front of the Navy more specifically and talk about underwater computers or machines and their ability to actually perform using our antenna-like devices. So if you think about persistent systems and everything he just shared, Chris just shared, you know, let's just say the plug and play is a difficult concept to his point, but it is a possible one. We also demonstrated at Trident Spectre. But let's say, for example, if we can enhance that capability, you know, up those baud rates, improve those distances and depths underwater with our devices. That's what we intend to do. So again, from a very basic proof of concept only piece of equipment, we brought our 30 megahertz carrier frequency designed software defined radio, which was hooked up to a video camera, the radios to shift this video to a 30 megahertz carrier frequency in the first place. We built it into an underwater, tight enclosure, hooked it up to one of our Saltenna antenna-like devices, and we showed again live streaming high def video at 5+ megabits per second. What we also did was we basically identified several things there conveniently. One of them is that the air to water interface is actually very possible for us to see across. We also noticed that, which we knew from our mechanism, which we can get into later, but that we have a very successful low probability of intercept, low probability of detect, low probability of jamming functionality due to the mechanism by which this moves. Again, the second half of this slide here basically just touts us as our DARPA electromagnetic program managers telling US Stratcom that we were quote unquote the biggest breakthrough in electromagnetics in 60 years. And again, our technology propagates at true surfaces. That's its distinction. It requires a conductivity mismatch. If you think the surface of the ocean where it meets the air, that's a perfect conductivity mismatch for us to use. So again, instead of sending information, video, basically energy of any capacity into a free space environment, we are going to hug along the curvature of that Earth, okay? So we're also useful in subterranean stratified layers, as I alluded to, and we can penetrate skiffs and Faraday cages fairly easily with very minimal power requirements, even up to full motion video, which again is what helped us get that USASOC and DTRA contracts. We can look at the projected performance envelope if we have time at the end, if anyone is interested. Next slide, please. Okay, so kind of continuing on, we believe that using our software-defined radio experts, we can actually bring our video system down to a 10 megahertz carrier frequency. We already mentioned the air-water interface there. And the important thing of note here with this technology is exactly that. Again, it is a plug and play, quote unquote, technology, right? You do take the persistent systems antenna off, you place our antenna on, now it works underwater, maybe better, maybe it requires some software advancements and electronics, some of the things Chris was alluding to be amended. However, it outperforms typically whatever antenna you had up there before. We actually proved this at Trident Spectre with L3 Harris 163s. Again, we set them to 50 megahertz. We took off their antenna, we plugged in our antenna with some rudimentary mechanical adapters just because it was an opportunity to try to break the system that Trident Spectre loves to do, and I loved it as well. And again, the diver and the assessors saw deeper depths and longer distances by far than they'd ever seen with an L3 Harris 163 underwater before, as I understand it. And then we used our actual prototype and showed even further improvements beyond that, only because ours was built for actually underwater. That all said, we can design this technology into different systems, as I was saying, radar dishes, microwave dishes, cable and fixed arrays, like what comes on submarines, again, for imaging equipment, monitoring equipment, even power transfer equipment. Okay, it starts sounding a little bit unbelievable at some point, and I try to avoid that, but the facts are the facts. Again, we're agnostic. And what I'd like to bring, hopefully next year, to Trident Spectre, again, probably rudimentary and basic proof of concept, but is a underwater sensor system, which kind of doubles as somewhat of an underwater radar system. So we're working on those basic concepts currently. Over the horizon radar, though, again, big problem. I know the Navy needs, for example, personally, again, that would be an excellent application of this technology. Next slide, please. So this was the system, again, super basic concept here. purpose, like I said, hey, this works. Look at these data transfer rates, right? Size, again, it was much larger than what we could actually do. We had no optimization or miniaturization of our antenna-like devices in any way, shape, or form. So whether it's bringing that form factor down to something just to strap on to a seal or diver otherwise, put in a UUV or whatnot, it would be really very simple. Next slide, please. This is an example of a recent experiment. You'll have to forgive the rudimentary environment in which we're operating. We're a very small business still. But on a mid-September day, I was out at my chairman's farm in his pool overlooking the environment. And basically, this is kind of the proof is in the pudding. And it's a poor picture and probably too small for this screen. But the bottom line is you see me standing in the pool there, 4 feet depth. Our antenna is on the bottom. Our antenna-like device is on the bottom. That is simulating where the submarine would actually be detecting or sensing from or whatnot, for example, in this particular experiment, quote unquote. And then I just had my video, say the periscope or whatever up top side, shooting over the hill. And that's in the bottom right. You see the hill, way off in the distance. If you could zoom in, which again, the system does not do yet, you would see all the animals up there. But you can see on the graphic display of the other larger screen there, the 6 megabits per second carrier frequency and bandwidth across that 30 megahertz. Next slide, please. So again, we talked about just the opportunity to break things at Trident Spectre and very thankful for that. Their vulnerability assessment team gave us a score of 100. They only graded 1 out of 4 categories. However, and there is a 9-page report that is also on Vulcan. Relatively inconclusive, and we'll get into that in a little bit here. But at the end of the day, there was an opportunity that we had where, again, we had our 50 megahertz system, so totally different system, but it works all the same, right, with this technology. We had the receiving end on one side of the marina. I was on a boat about 30 feet away, whatever it was, on the other side. And we had the vulnerability assessment team trying to sniff us, quote unquote, detect us and whatnot. They knew exactly where we were, clearly. They had our signal pegged. When we were above water, they saw the signal even 1 to 2 inches literally below water. My receive still was received from my transmit side. And again, we faded into background and they didn't know we were there anymore. So this is just an example of generally how the technology works, right? Again, it requires a surface. It finds its quote unquote path of least resistance or conductivity mismatch that we talked about before. So you could have 2 submerged objects here, for example, literally, communicating up to the surface, right? Wireless, this is all wireless, by the way, right? So they're at depth, the communication is taking place along the surface to each other. Anything you can do with sonar or any kind of, RF, you can do to this technology. Again, it's just a matter of building it into your system. So here, for example, the adversary's submarine could be right in the middle of these 2 vessels. And first off, they don't have the technology to be able to intercept us in any way or even detect us. And then secondly, they'd have to be looking up at the surface and not in the water with some sort of acoustic or otherwise listening device. Next slide, please. We already went over low probability of intercept, detect, and jam by its mechanism of propagation. I hope to have shown this. And again, like I said, nobody else has a technology in the world as we're familiar with. So the ability to do these things is a capability all in itself, aside from what I'm sharing with you about the amount of information we can push underwater or subterranean environments. Next slide, please. Talked about the score of 100. When it comes to jamming, it's a big question, right? Another big problem. Again, if you think about the way energy moves, you can flood a space, whether it's a skiff or any space with a whole lot of energy. Some of it's going to bounce along the surfaces, right? But it's not going to connect to them. It's not going to couple to them. It doesn't use them. So you would need to put an immense amount of energy to even come close to defeating our energy propagation path along the surface. Just something of note to point out. Next slide, please. So, again, we got in front of Trident Spectre, great ideas, great words, great just opportunities with various people, as Paul said. We're putting these highlights into actions, right? So these are some of the quotes, high-level quotes. They recognize the novel, differentiated, and superior technology, vice, other things like acoustics and lasers in similar environments. We don't have to compete against those people, though. We can complement with anybody, right? So it's just a matter of, how many antenna-like devices can you fit on your human, as Chris mentioned earlier, or otherwise machine, and provide various opportunities of communications and energy transfer. Again, we are non-line of sight transmissions with high bandwidth. They recognize that. And that game-changing technology was in existence there at Trident Spectre 22. Skepticism did exist among some of them, and I continue to be trying to expand people's horizons of understanding this technology exists, that it is obviously out there, it is working, it is in fact using plasmons, which was the exact comments. They said that if it is using plasmonic technology, it is a game changer. I believe the technical assessment team did, in fact, believe that we were, which they are correct. We have a full assessment available upon request, obviously, or it's on Vulcan. Next slide, please. So again, what else did they see? They saw our successful demonstration that it was undetectable with 100% score from vulnerability, and other comments, SIGINT system on any comms link, extremely valuable, again, due to the mechanism of the technology as we expressed. And ultimately, they said that it was a major accomplishment in the field. Next slide, please. Are there any questions, comments, or concerns? Or I'm happy to put up the next slide and final slide, which is a projected performance envelope from a diver's perspective or otherwise.
Thanks, Mark.
Do we have any questions?
Okay, we do have some questions, so thank you again to all of our speakers, and I'm gonna turn it over to Eileen. But what I am gonna do too is I'm gonna put up our last slide here. So a couple events coming up for the Trident Spectre Industry Day, which we talked about. We've got a couple other interesting tech talks coming up, and you will have the links to those. It's just on our Eventbrite page to go out and sign up for. And then we kindly ask you to take a quick survey. So if you have your phone sitting right by you, scan that QR code. 4 questions. We would really appreciate your feedback on these tech talks that we're doing. So with that, I'm going to turn it over to Ms. Eileen to read the questions, and we'll get some answers.
Great, thank you. We do ask that you complete the survey if you're interested in receiving the deck today. So if you would like to receive the deck, you need to complete the survey. We have a question for you, Paul. There was in your comments, you mentioned that the selection criteria had to do with stakeholder metrics. Are those stakeholder metrics shared?
No.
No. And do you know whether or not stakeholder metrics include things like vessel range, speed, power draw?
They do not.
Acoustic signature?
They do not.
They do not. Okay.
The metrics are based on things like, does this technology perform against a peer adversary? Does this technology have a maritime application? Those are the types of metrics that are being graded against.
Okay, great. And we'd like to hear, those are the only questions we have so far. So we'd like to hear from any of you. You can unmute yourself and ask your question, or you can type it in chat. Either way, we have about 5 minutes that we can answer questions. There was another question asking about whether or not you had to know if you were accepted into Trident Spectre before you attend Industry Day. And the answer is no, you don't need to know. You don't have to be accepted into Trident Spectre to attend Industry Day. You can go ahead and register. It's open for everyone. I do believe that they've hit max capacity and they're at waiting lists now. So, but feel free to get your name on the waiting list. Other questions?
I don't have a question, but if I could have a second or two, Tina, I'd like to just throw some information out there if that's okay.
Sure, go ahead.
So just for everybody, I've got a unique perspective. I obviously am now working in industry, but prior to that, I was actually at Group 8 and did run Trident Spectre. And I also, before I retired, I had an opportunity to work at Naval X over at Naval Postgraduate School. So I've been like in this environment for quite a while. And one of the big things to emphasize is there is nothing out there that does what Trident Spectre does. You can look across services, you can look across different components. You're just not going to find anything that allows you to bring your equipment and flex it to the max extent with user feedback. You can't fail at Trident Spectre. The only way you fail at Trident Spectre is if you don't try and push your capabilities to the limit, and if you don't leverage the resources they provide. Everything out there that tries to replicate this or has done something that is similar to this ends up turning into a trade show. And that's the one thing that the staff there has done a really great job, is not turning it into a trade show. And also creating an environment that fosters, the fail fast mentality, instead of, you bring it to Trident Spectre, it doesn't work, and now you got a bad name. Like, none of that ever happens. It's, if you're pushing your system to the limit and you're collaborating with other organizations, that's the ask. And as long as you're doing that, it is rewarded. Just some information for the group.
We have another question about how do they get a sponsor? How do they find a sponsor?
So there's two ways you can get a sponsor. Number one, you can solicit somebody that you know in the government. But once you submit your project to Trident Spectre for the call, we will advertise your project to, if you don't have a government sponsor, to would-be government sponsors to reach out and sponsor your project. So the Trident Spectre staff will, once you submit your project, if you don't have a government sponsor, present that to would-be government sponsors. So there's another avenue. We can't guarantee sponsorship, but we can guarantee that we will advertise your project to would-be government sponsors.
So then in that case, somebody says, yes, I'm willing to be their sponsor, then they would reach out directly to the submitter.
So there's two ways they do that. So number one is, yes, they reach out directly to the submitter. The second way is they put themselves down as a sponsor, as a nominator in Vulcan on the call.
And then the submitter can see that?
Submitter will get a notification.
Oh, that's great. Okay.
Good. I think unless there's any more questions, which we didn't see any pop in, we really thank you for your time. And again, you'll see at least some of these slides with the links to them to get you access to the events that are coming up. But thank you again to our speakers, and we hope you all enjoy this talk.
Thank you.
Thanks, y'all.
Thank you.